So here it is, the continuous mining unit video where I show you from start to finish on how I use the system to extract and concentrate ore into a finished metallic powder and actually melt it into a bar, as you see here. So this is about 2 ounces of material that I produced using only 2 cents worth of electricity. It is just a concentrate. It's very heavily unoptimized and there's a lot of room for us to go, but it's a pretty amazing step, as many of you requested to see a finish to end videos. I do want to start off this video by thanking personally all the amazing people that have helped me with this project. Firstly and most importantly is a member called Mysterious Boys. He's a very amazing chemistry YouTuber and he's helped me a lot with understanding chemistry and electrochemistry and so forth. He has a lot of his own greater ideas on how to help this project, but him and also another individual called Edgekozan, he's on my Discord server that you can meet, and they've already came up with a way to improve the ion exchange membrane process and make it more powerful and conductive. So I'll make a dedicated video about that. I just want to again thank everyone else that's helped me throughout this whole process and these many hard years of work. Here it is, the video, and I do want to start off or finish this intro with, please watch the safety video first. This is only for research and demonstration purposes. This is not to process or to make money off of. Although yes, this is 2 ounces of material and even just the scrap weight of this is worth more than 2 cents. This is only 15 cents worth of lead, mostly currently, and you're not gonna make a living off that. So please, this technology has a lot of optimization and there's a lot of risk around it, but we're working on that, and our next step is to scale this up to a tonnage per day capacity. We already have a vacuum filtration drum. I'll make a more dedicated video about that. We're already working on scaling this up very short. We will have that a trailer size unit, but that will be portable and can process lots of feedstock. So anyways, thank you and continue watching. So again, we have it flow into the chamber from the bottom, from the pump. It flows into the negative chamber. From here flowing, it goes into the bypass port, and it is hollow inside of here. And what this allows to happen is the leach solution, again, it goes into here, plates off all the metals, gets depleted, flows back into the positive side. By going back into the positive side, it'll feed back into these graphite electrodes, get regenerated through the ion exchange membrane. This is a cation exchange membrane that I've also open sourced and filed a non-provisional patent for and open sourced it under a non-open source license. You can find details of this membrane, the patent, and the open source information on the GitHub linked on the video. Alongside with these graphite electrodes is another patent that I'll have to file and open source because it's a very unique way how I assemble them. But don't worry, I'll release that video pretty soon. But I am using graphite gouging rods boiled in linseed oil. I'll make a dedicated video explaining about how I make them. You can use glassy carbon, many other electrodes, mixed metal oxides, whichever electrodes you use. Point is, that is on the positive side, it gets regenerated and gets flowed back into the leaching tank, where then it further leaches the material and continues the cycle. For the chemical solution, I use hydrochloric acid and a little bit of sodium chloride. This produces the foundation of the chemical leaching solution. Again, I have presentations that go far deeper into the chemistry behind this, but in short, to make the solution, I use muriatic or hydrochloric acid. This is a 32% solution purchased from the hardware store, pool supply store, doesn't matter. It doesn't have to be anything special, anything fancy. Just make sure it is proper concentrated hydrochloric acid. There's a lot of grain and diluted and substitute hydrochloric acids. Don't use them. With this, I mix 2 gallons, 2 bottles to 1 5-gallon bucket. This results in about a 10 to 15% solution of hydrochloric acid. With that, I fill it into the electrolysis cell and leaching tank, sufficient just to cover over the leaching material. You want to minimize the overall amount of solution used because in electrolysis, you will always have a little bit left dissolved, right? It's not something that you can plate off and reduce down every single last atom. So by reducing the overall amount of solution, you're able to minimize those losses. Now, in a closed loop, continuous operations, those aren't losses because they'll simply be pushed out by a new feedstock being put in. But in a test research case scenario, you want to minimize those because you want to have a full and analytical analysis of exactly how much material gets separated and plated off. For the salt, you do not want to add too much. In some cases, you might not even have to add any because the calcium in the ore would actually act as a calcium chlorate and provide the chlorate species in order to produce the high ORP levels. However, you also don't want too much salt. If you have too much salt in the solution, you'll actually prevent gold from being plated off. It forms some sort of weird complex. But point is, I typically like to add around less than 5 grams per liter of salt. In some cases, I don't even add it. It gets into very complex chemistry of the purpose behind it and the reasons behind it. Again, I'll make a dedicated video about this, but 5 grams per salt is enough. Another topic to discuss about is ventilation. Even though we're outside, gases build up, gases accumulate, and it's very important that we have some sort of ventilation. And this is not the only method I have. I have a short video where I show a teaser of a scrubber system that I'm designing and I'll be releasing soon. But again, ventilation is very, very critical. Doing it outdoors is very, very critical. This is not something you do inside. Gases will accumulate. Chlorine gas, hydrogen sulfide, fluorine gas that comes from the material and feedstock that you're processing. You might not even know is in there if you don't have the right analytical equipment. Again, watch my safety video. But point is, it's very, very, very important to have a scrubber system, a ventilation system, and so forth. Please. I'll be releasing more videos about this topic and how to build a proper scrubber system and releasing my own products soon that people can actually purchase themselves. But this is something to not underestimate, to not do until you get it done right. Another critical safety aspect is the secondary containment. Not only are both of these things, the ventilation and containment, required by the EPA, it's pretty much common sense, right? You don't want spills and accidents to leak out into the environment, to leak out into the overall workspace. And that will happen. That's just a fundamental fact of doing research and prototyping and experimenting is you will see that happen. And just having this little setup makes things far more easier to work with. For the material, I'm using a PVC vinyl shower pan liner. You can purchase at the local hardware store. Just make sure it's resistant against the chemicals that you're working with. In my case, it is. Since it's a PVC-based material, it works absolutely fantastic. I could even glue a drain port or some PVC pipe to the flexible sheets and have a pipe connected to a pump in a worst case situation. But for this case, it's fine. Just make sure that the containment is the same or greater, preferably twice the amount of volume as the amount of liquid that you're going to be working with. For the leaching tank, it's nothing crazy, nothing special. I'm just using this regular fiberglass window screen. Again, you want to use material that's resistant against the acid. And the purpose of this is so I can put this on top, and that way it'll dampen the flow to go better around. After that, I place some of this blue aquarium filter and stack it around. Again, the whole point of this is just to distribute the flow as best as possible around the hole. We are currently waiting for a continuous vacuum filtration drum to completely eliminate this whole section and make it fully continuous. But this is something that's very nice for testing small amounts batch-wise. Finally, I'll be putting this dewatering bag inside. It should be fitting a ICB tote, but again, for small batches, this works. And it has these nice hooks that can be then lifted out with a crane, an excavator, so forth. These are nice way to keep all these sediments away from the rest of the system. It's not perfect, it's not a great filter, but it allows you to handle the material afterwards easier rather than going in here and trying to scoop it out, which is not fun. Alrighty, now we're actually gonna fill up the system. So we're just gonna use our 2 gallons for every 5 bucket. Just eyeball, doesn't matter, nothing crazy. And while I'm doing this, I have a fan facing towards me so that I don't breathe in the gases. Even though this is sold at hardware stores, even though people use this for pools, it's very important that we do this safely. I just cut a hole in the back so that it can properly vent through and drain without it regurgitating like that, which splashes a lot more. For this case, I'll add the water first. That way the fumes aren't as strong, because the hydrochloric acid, once it reaches its higher concentration rates, it starts to fume out a lot more often, or a lot more easily. So adding the water a little bit helps with calming down the fumes. Now we're gonna go ahead with our 2nd gallon and then top off the rest of the bucket. We're not gonna fill the bucket all the way up. Again, the ratio just has to be around 10 to 15%. There's a lot of variabilities that you can play around, and again, it's research, so please play around with it, right? Experiment, see, try to do various tests. But for the leaching tank, I'll fill it up about 1/3 of the way just to get to the bottom of and I'll add more solution later once I start putting in my feedstock material. And this tank, I'll fill it up all the way somewhere around near the top so that I know that this is full, and then we're gonna run the system. Now that we have everything hooked up, I'm gonna do one final review just so we're all on the same page. So again, on the positive side, we have graphite electrode rods that regenerate the acids. This regenerated acid gets flowed into the leaching tank. Currently, this is just a leaching tank setup, and I'll make a separate dedicated video for about this step and about how to make the graphite electrodes. But for now, this is just a leaching tank. The acid simply leaches through the rocks, leaches out the metals, turns into a dissolved liquid, a salt. That leach solution from the bottom of the tank gets pumped through a mag drive pump. The mag drive pump is chemically resistant to resist the acids that the system produces. Here on the negative side, it has titanium plates as the negative electrode, which will plate off the dissolved metal salts, the dissolved metals, off as a powder, which will then fall to the bottom in this cone tank and get collected here in the bottom, where we then tap it off with a valve. Also in the bottom, I have a titanium bolt that I keep also polarized as a negative, as a cathode, in order to protect the falled off powder from redissolving into the acid. Finally, the depleted, plated off solution gets flowed back into the negative side through this bypass chamber, where then it regenerates through the cation exchange membrane, which I also have a separate video explaining how to make, but it gets regenerated through the cation exchange membrane, regenerates on the positive side, and repeats the cycle. Additionally, we have a fume hood system specifically on the positive side and the leaching tank, because as the metals gets leached by the chlorine, hydrochloric acid, they'll produce some chlorine gas. Additionally, as it gets electrolyzed, it'll produce some chlorine gas. That is run through a scrubber system, which I'll make another dedicated video about, and this is a very important step. Do not skip it, because the chlorine gas produced is very dangerous, very corrosive, not good. Additionally, as you see, this is not something you do inside. You do this completely outside because it is dangerous. Gases will collect and cause problems in an enclosed environment. So it's very important that it is in a ventilated environment with a scrubber system, and also in a secondary containment system that will collect any leaks that may occur. Additionally, with the tank, Since I am doing a leach-wise process, we have it designed where it can be easily slid off. I can add extra amount of ore and slide it back on to be enclosed. As the system is running, in order to make sure it is in proper leaching conditions, we will test the positive side. And as you see, it is still mostly acidic. A little bit is turning white, but we want to keep running the system until it starts to turn the pH paper completely white very quickly. That shows us a very good sign of when the ORP levels is high enough to be able to dissolve gold and other precious metals. Another important instrument is to have a chlorine dioxide meter, which allows you to measure the chlorine environment around and make sure you're below limits. Typically below 0.5 parts per million is the EPA limits at one or below the limits that you need to measure, but still it's good to have this just in case, just to be able to measure. Although this does primarily only measure chlorine dioxide, it's still a very handy tool. Additionally, be careful about mixing the gases on the positive and negative side, as on the positive side, chlorine gas gets produced, on the negative side, hydrogen gas gets produced, and of course that's dangerous to mix as it can become explosive under a spark or other ignition points. All right, it's been some time. We'll now check the oxidizing potential. As we see, it turns bleach white very quickly. It's a very good sign. That means this is bleaching and working under optimal conditions. We'll also be measuring with this ORP level just to see how it's functioning. Now this ORP level only gets to 1,000 millivolts. So if you want to help support us and get to be able to purchase better equipment, please check out our GoFundMe. But almost immediately it gets to 1,000. Not almost immediately, but literally immediately it gets to 1,000. So the theoretical of this should get to over 1.5 volts. So 1,500 millivolts. That's a theoretical, but we of course don't have the proper equipment to be able to validate that. So again, if you want to help out and support this project, please check out our GoFundMe, our website where you can donate, and our Patreon. Helps us purchase the required equipment, required materials, required chemicals, and so forth to conduct our tests and research and progress this development. Alrighty, so we've had this ore leaching for a while. Now this is a Galena type ore, so it has a lot of lead in it, silver, but we've confirmed that it does have platinum group metals and some gold in it. But as we see, it is mostly plating off as a sponge. This is a very common phenomenon with lead, where it actually forms a sponge and you can actually see the bubbles forming around it. So when I tap this, when I tap it off, you're gonna see it mostly float to the top. But you also see some collecting at the bottom already, and it's mostly around the bolt that is also being touched by the negative polarity as a cathode, so it's also protected. But I'll just slightly tap this. In fact, we're going to take off this whole electrode just so you can see how much material is produced in a very quick amount. As you see, it's all falling down and collecting at the bottom. Now keep in mind I have all this in a container, so a little bit of spills isn't an issue. Now keep in mind, although it is floating at the top, that's a very easy problem to solve by simply adding a vibrator or ultrasonic transducer onto the negative electrode. As we see how much is being collected, it's an enormous amount. Though I can tell almost all of this precipitate is mostly lead. just based off experience. The other thing we can do is simply squeeze the lead out, squeeze those bubbles out. Again, once we get a proper vibrator, ultrasonic transducer, it'll fall off completely as a powder. Currently, also for this setup, I have a secondary cation exchange membrane. So I actually have two cation exchange membranes. The reason why is because with this lead, as you see, it's all floating and just getting all over the place. So in order to prevent it from backflowing back into the positive side, I simply use a secondary cation exchange membrane. But we can see it mostly collecting here in the bottom. And this is where our nice valve design comes into play, where we simply put our cup, open the valve, and get our heavy metals pouring right out. This process can also be automated through again, a continuous vacuum filtration drum. By having the powder continuously pumped through a vacuum filtration drum, we can continuously separate the precipitated powder from the liquid. As you see, we have our beautiful liquid here, and you see some of the shiny metal, which isn't lead. But this is all of our mixed heavy metals from the ore that we leached out. And then this excess liquid, as you see, once it settles off, we simply pour back the remaining. Though again, this optimally would be fully automated. So after we've collected our powder, we're gonna now run it through a vacuum filtration. This is a regular vacuum filtration, not a continuous drum one. Collect the paper and dump the powder. We're gonna do this to fully dry out. Dry out the powder and get a final measurement. Another thing that can be done is actually first running this powder through or washing it with baking soda, so it neutralizes the solution, because the solution is still very acidic, right? So you kind of want to filter it as soon as possible after you collect it from the electrolysis cell, because otherwise it's going to actually keep redissolving back into solution. So one solution to that is simply by washing it by baking soda, so it fully neutralizes it all and you won't have problems. But as you see, we're just going to wash it a couple times and then cook it off. So here it is. After running all that, we have about 85 grams of this concentrate. Now, again, this is mostly lead, and one thing I want to emphasize is by the time I filtered it and washed it and did all that, the unit already produced almost this much. And so it produces this much in about 30 minutes, 40 minutes. So yeah, another thing to also emphasize is the whole setup is incredibly inefficiently set up. You want to properly calibrate how much flow rate is going in versus current density versus leaching capacity. So all that can be calibrated, and easily you can increase the economics by 10 times. But even then, even with this concentrated amount, so at 85 grams, we've run this electrolysis cell at around 45 amps, running at let's say 6 volts, right, which is what we're running. But you can actually reduce voltage. By reducing voltage, you get far more efficiencies, but running at 6 volts, incredibly inefficient. We get around 135 watts of electricity used to produce this amount. Okay, so 135 watts of electricity. because we've only run it for half an hour. That would equate to about 2 cents of electricity at very high residential price of 0.15 cents per kilowatt hour. Now, industrial prices are half of that. So even just running this lead scrap, I end up producing around a 5 times fold if I just sell that scrap. But this lead, pure lead, is sold at, this 85 grams would end up being around 12 cents of lead. So I would use 2 cents of electricity, and just the lead value in itself is over 6 times of that. I'll do a much more deeper dive into the XRF analysis and spectrum, and that's towards the end of the video, but honestly, that's something that requires its own video. It's a very, very deep topic, and I do have an existing video about XRF analysis and its flaws and issues, but it's the best thing I have. However, I will put on screen here a third-party analysis by a user called Neptunium, and I've had other third-party analysis, but this one specifically is done by ICP-MS, where he showed and proved that I am able to and have extracted gold and rhodium and platinum and palladium and all these other platinum group metals, iridium, right? All the platinum group metals, all the precious metals I've successfully been able to extract using this salt electro mining method. So it's such an amazing thing to see. It is disappointing because I'm very limited based off the tools I have, as amazing as this instrument is. So again, please, if you want to help support this project, one of the things we're trying to do is raise funds to buy ICP-MS and ICP-OES ourselves, and that's about a $10,000 piece of equipment purchase. So, you know, if you want to help out, but yeah, I can't emphasize enough. So when a quick short summary on the XRF analysis, we've already showed rare earth elements, critical minerals, nickel, copper, yttrium, so on and so forth, and I have so many more XRF analysis where I do show I extract platinum and gold and so forth when the lead isn't so high. That's one thing that's just a problem. As long as the lead isn't high, then XRF is a lot more reliable. But so I'm very proud of this project. I'm very proud of the results, and I understand the impact it has, and that's why I've open sourced this, and I'll keep open sourcing, and we've only scratched the surface. So please, if you want to help support this project, check us out on Patreon, maybe visit our GoFundMe to help purchase the ICP-MS machine. Any amount that goes through the GoFundMe, any amount that goes through the pretty much anything regarding this project goes completely back to the project. It doesn't even go towards my personal living expenses, though I kind of have to start changing that soon because I can't be making this a full charitable donation, right? I need to survive somehow. I've been working on this project for about 3 years now, and I've sacrificed my personal life, my family, I've sacrificed a lot. I've lived bare bones, and pretty much every dollar I've made, I put back into this research and continuing this project. But I see a very great opportunity forward. We have successfully raised enough money and have already purchased a continuous vacuum filtration drum. I'll make a dedicated video about that topic, but in short, it will allow us to scale this technology from a 55-gallon drum or 5-gallon buckets worth of ore to tonnage per day capacity. So that's a really, really huge thing for us to take a move forward. Thank you very much to the people that have donated to that. Yeah, but there's still so much more left to get this properly done. We'd like to be able to purchase injection molding machines to be able to mass produce these electrolysis cells. We'd like to purchase better analytical equipment to properly do this. We'd like to purchase other manufacturing equipment to properly be able to produce this. We'd like to do more research into the electrodes to properly optimize that and create an electrode that doesn't last a couple of months, but rather something that lasts years or even decades. We'd like to research more into the ion exchange membranes themselves and separation process, where we're actually able to have a system where you just feed the leached solution and it separates each individual element on its own. We like to produce aluminum and sodium metal directly from a aqueous solution through an ion exchange membrane into a different solution in order to plate it off as a metal at room temperature. I can't stress this enough, right? We've only scratched the surface, and we have all this vision, all these opportunities, all these ideas to venture into and utilize this technology into. I see this as the next frontier, of the next standard of industrial mining. It makes no sense to do any other process. We produce absolutely no waste. We completely regenerate all of our acids. We are incredibly economical, incredibly high extraction rates. I can go on and on and on, but again, this is the future. It just takes someone to actually do it. So if it's not me, it's someone else, but please, someone has to do it. And if you see my potential and see my skill sets and see how I'm able to come up with very creative solutions that is actually practical at scale. One of my favorite quotes is that anybody can build a bridge that crosses the Atlantic Ocean. You give an 8-year-old child infinite money, infinite time, he will build you a bridge that crosses the Atlantic Ocean. It takes an engineer to build a bridge that can cross a small canal on time and on budget. And that's my skill set. That's what I'm very proud that I can identify that I do. You know, I was able to do this on such an incredible small budget. This entire lab, this entire facility space, I completely built myself. But some learning lessons, primarily with this analytical equipment, is not everything can be DIY, not everything can be just scrapped together. Some stuff really requires money. You know, this analytical equipment costed a lot, but hey, it's helped so much. And whenever I get these funding opportunities, whenever I make the next step, it takes me so much farther. But definitely for now, I see the vision of this technology as getting very close to a point where it'll become self-sustaining, because I shouldn't be, and I can't be relying off donations forever. This technology, this company, this development needs to be self-supporting, and I see some opportunities for that. So I've been saying this a lot, but I really want to launch certain products. For example, a scrubber system so that people can do a lot of chemistry safely at home. I want to launch some copper refining and silver refining, even gold refining electrolysis cells, so people can refine their own metals at home. Again, the problem is this is all very dangerous stuff, and it shouldn't be done at home. Eventually it can get to a point, but I have to take small steps forward. So for now, we're very limited based off who we deal with, based off who we sell to, who we supply to. And one day I do eventually see that this technology can get to a point where it can be safely run at home, but I do want to stress this enough. Watch my safety videos. Don't run this at home. You're not gonna make money, right? Again, this amount, right, 15 cents. You're not gonna live off that. You're not gonna survive off that. You're gonna be making less than minimum wage. This is one misconception I do want to emphasize, that ores and mining is a tonnage per day. Fun and have dialogue with me, and dialogue with everyone else part of this community. And most important is, again, completely for free. You don't have to pay any of that. I do want to emphasize that I do provide opportunities, and my philosophy is that knowledge should never be charged for, right? A lot of people suggest I sell a book or sell instructions or sell blueprints. I'd never do that. I sell my time, but I don't sell my knowledge. My knowledge is completely for free, which I publish on YouTube. So again, thank you very much. There's a lot that I'll be releasing in the next couple of days. I've been formulating an open source charter regarding ROA LLC and the whole open source philosophy and how that will be all structured, and so many more. I'll try to keep this video short so you guys are gonna click off too soon, but anyways, thank you for watching. If you're a mining company or someone else with a feedstock that you want to run through a salt electro mining unit, well, reach out to me at info@rowout.net. And this is one service that I'll be launching soon, so that instead of you having to set up your own system and go through a learning curve of trying to operate it, optimizing it, and so forth, you can just send it to me and I can send you back the concentrate sample to validate it for your feedstock before you decide to move further with this project.